The date was August 31st, 2025. Across the planet, millions of us were gathered around our screens, united by a shared sense of wonder. We were watching a live feed from a NASA space telescope, its gaze fixed upon an interstellar visitor named 3I/Atlas. This object, a traveler from another star system, was putting on a spectacular show. It glowed with an eerie, unfamiliar light, its behavior defying our neat and tidy classifications of what a comet should be. The energy in online forums and social media was electric. We were explorers, all of us, venturing into the unknown from the comfort of our homes, witnessing a cosmic event for the ages. Then it happened. In the middle of its closest approach, just as the telescope's instruments were collecting the most crucial data, the screen went black. A simple, stark message appeared. Feed terminated. There was no warning, no explanation, just an abrupt and total silence. For a moment, a collective breath was held. Was it a technical glitch, a power failure? The initial confusion quickly morphed into a tidal wave of questions and speculation. We were staring into the heart of a cosmic mystery, and someone had just slammed the door shut. The silence that followed was louder than any celestial explosion. It was the sound of a story cut short. The immediate aftermath was a digital firestorm. People who had been sharing their excitement just moments before were now sharing their frustration and suspicion. The hashtag #NASA cut the feed trended worldwide within minutes. We had been promised a front row seat to the universe, a moment of shared discovery. Instead, we were left in the dark, staring at a blank screen that felt like a betrayal. Why now? Why at the most pivotal moment? The sudden severance of our connection to 3I/Atlas felt deliberate, almost surgical. It wasn't just a loss of data, it was a loss of trust, a severing of the link between the public and the cosmos. This single act transformed the 3I/Atlas event from a scientific curiosity into a global enigma. It was no longer just about a strange object passing through our solar system. It became a story about information, control, and the deep-seated human fear of the unknown. We looked to the stars for answers, for a sense of our place in the grand cosmic scheme. But in that moment, the stars were taken from us. The silence from NASA was deafening, creating a vacuum that was quickly filled by theories, some plausible, some fantastical, but all born from that single jarring moment when the universe, for all we knew, went silent. To understand the chaos that followed the feed cut, we must first understand the guest that caused it. 3I/Atlas was not just any comet, it was an interstellar object, the third ever confirmed to have visited our solar system. Imagine a traveler who has journeyed for millions, perhaps billions of years through the vast, empty darkness between the stars. Its home is a star system so far away we may never know its name. This traveler, this piece of another world, had finally drifted into our celestial neighborhood. Its name, 3I/Atlas, tells its story. Our 3I for the third interstellar object, and Atlas for the survey telescope in Hawaii that first spotted it. Unlike its predecessors, Oumuamua and Borisov, 3I/Atlas was different from the very beginning. Its sheer size was staggering. Early estimates placed it at over 50 kilometers in diameter, making it less of a celestial snowball and more of a small moon hurtling through space. This was a giant, an ancient relic from a part of the galaxy we've only dreamed of. Its journey through the cold, lonely void should have left it dark and inert. Yet as it neared our sun, it began to behave in ways that baffled astronomers. It wasn't just a passive wanderer, it seemed to be an active, dynamic entity, a cosmic puzzle waiting to be solved. The path it took was also peculiar. Interstellar objects are expected to follow a specific type of orbit, a hyperbolic trajectory that slingshots them around our sun and flings them back out into deep space. While 3I/Atlas was on such a path, its movements contained subtle, inexplicable deviations. It seemed to change its course ever so slightly, as if nudged by an unseen force. These were not dramatic Hollywood-style maneuvers, but tiny, persistent adjustments that our best models of gravity and solar radiation pressure couldn't fully account for. It was like watching a ship adjust its rudder in the cosmic ocean. This combination of immense size, unexpected activity, and a slightly anomalous trajectory made 3I/Atlas a scientific goldmine. It was a once-in-a-generation opportunity to study material from another star system up close. What was it made of? How old was it? What could it tell us about the conditions around its parent star? These were the questions that had scientists around the world buzzing with excitement. This uninvited guest was more than just a rock. It was a time capsule from an unknown corner of the Milky Way, and it was knocking on our door. As our telescopes focused more intently on 3I/Atlas, the list of its strange characteristics grew longer. A normal comet is essentially a dirty snowball. As it approaches a star, the ice on its surface sublimates. It turns directly from a solid into a gas. This process creates a glowing coma, a fuzzy atmosphere, and a beautiful tail of gas and dust that always points away from the star. This is basic comet behavior, something we have understood for centuries. But 3I/Atlas refused to play by these rules. It was far more complex and far more active than any comet we'd ever seen before. For one, its brightness flickered in a non-random pattern. Instead of a steady, predictable increase in luminosity as it absorbed more solar energy, 3I/Atlas pulsed with light. These pulses were rhythmic, almost like a slow cosmic heartbeat. Spectroscopic analysis, which breaks down light to determine an object's chemical composition, added another layer to the mystery. It revealed the presence of heavy metals and complex organic molecules in its coma, materials not typically found in such abundance in comets from our own solar system. It was as if this object was made of fundamentally different stuff. Furthermore, the object exhibited what appeared to be controlled fragmentation. Small pieces were observed breaking off from the main body, but not in the chaotic, explosive way a comet nucleus typically disintegrates under thermal stress. Instead, these fragments seemed to detach and then maneuver away, following their own distinct paths. It was a bizarre, almost biological-looking process, like a cell dividing. This wasn't the violent, messy death of a comet. It looked more like a deliberate, organized deployment. Each new observation only deepened the mystery and moved 3I/Atlas further from the category of comet. This strange behavior led to a fundamental debate. Was this even a natural object at all? The evidence was piling up against it: the pulsing light, the unusual composition, the controlled fragmentation. None of it fit our models. Scientists were forced to consider possibilities that stretched the boundaries of conventional astronomy. We were faced with two choices: either our understanding of comets and interstellar objects was profoundly incomplete, or we were looking at something entirely new. Something that wasn't born from the random chaos of planetary formation, but from a deliberate, intelligent process. Into this swirling vortex of scientific uncertainty stepped Harvard astronomer Avi Loeb. He had previously made waves with his hypothesis about Oumuamua, our first interstellar visitor, suggesting it could be an artifact of an alien civilization, perhaps a solar sail or a probe. With 3I/Atlas, he took his argument a step further. Loeb proposed that the object was not just an artifact, but a fully functional piece of technology. The rhythmic pulsing wasn't random, it was a signal. The strange chemical signature wasn't natural. It was the exhaust from a propulsion system. The controlled fragmentation wasn't disintegration, it was the deployment of smaller probes. Loeb's hypothesis was bold and, to many in the mainstream scientific community, a leap too far. Science prefers to exhaust all natural explanations before turning to extraordinary ones. Skeptics argued that we were simply witnessing novel but entirely natural astrophysical phenomena. Perhaps, they countered, comets from other star systems have wildly different compositions and behave in ways we haven't yet discovered. The pulsing could be a result of its rotation and irregular shape, and the fragmentation could be caused by unique internal pressures. They called for caution, reminding everyone that extraordinary claims require extraordinary evidence. The debate raged in scientific journals and online forums. On one side were those who saw 3I/Atlas as a message in a bottle, a relic of a distant civilization sent out into the cosmos with no specific destination. It was, in this view, a piece of alien archaeology. Its strange behavior was simply its ancient systems reacting to the heat of our sun. It wasn't directed at us, but we were lucky enough to witness it. This idea, while controversial, was at least palatable. It painted a picture of a universe that was once, or still is, populated by other intelligent life, leaving behind fascinating artifacts for us to find. But Loeb's theory had a more unsettling implication. If 3I/Atlas was a functioning piece of technology, was it just a passive probe, or was it something more? The sheer scale of the object made the idea of a simple probe seem unlikely. Why build something the size of a small moon just to explore? This question opened the door to even more dramatic and frightening possibilities. The message in a bottle theory was comforting, suggesting a universe of curious explorers, but the alternative was that this was not a message but a messenger, and we had no idea what its intentions were. As the official silence from NASA deepened, a more extreme theory began to take root in the fertile ground of public speculation. It moved beyond Avi Loeb's idea of a passive artifact and into much darker territory, the hostile tech theory. This hypothesis proposed that 3I/Atlas was not just an active probe, but a reconnaissance vehicle, or worse, a weapon. Its immense size, its strange maneuvers, and the deployment of smaller objects were reinterpreted in a sinister light. It wasn't exploring, it was surveying. It wasn't fragmenting, it was deploying drones. The object's passage was no longer a moment of wonder, but a potential threat. Proponents of this theory pointed to the object's trajectory. It was making its closest approach not just to the Sun, but to Earth. Was this a coincidence or a calculated orbital insertion? The rhythmic pulsing was no longer seen as a benign signal or a natural phenomenon, but as a form of scanning, a deep space radar sweep of our planet and its technological capabilities. The sudden feed cut in this context wasn't a technical glitch, it was a deliberate act of censorship. The authorities, the theory went, saw something that confirmed the object's hostile nature and immediately moved to prevent public panic by cutting the feed. This narrative contrasted sharply with the sparse official statements that eventually trickled out from NASA. The agency attributed the feed termination to a pre-scheduled data downlink and recalibration of the telescope's sensitive instruments. It was, they claimed, unfortunate timing, but a necessary procedure to protect the hardware from the intense radiation and particle shedding from the object at such close range. They dismissed the hostile tech theory as baseless speculation, the stuff of science fiction movies, not serious astronomical inquiry. They insisted that 3I/Atlas, while unusual, showed no signs of being anything other than a natural object of interstellar origin. But for a public already primed for suspicion, the official explanation felt thin and convenient. Why perform a recalibration during the most critical moments of the flyby? Couldn't it have waited? The discrepancy between the dramatic event we had all witnessed, the silent black screen, and the mundane, bureaucratic explanation created a chasm of distrust. The hostile tech theory, however outlandish, offered a narrative that fit the facts as the public saw them. It explained the object's strangeness, and most importantly, it provided a compelling reason for such an abrupt and total information blackout. The whispers of a threat felt more real than the official reassurances. Let's take a closer look at NASA's official explanation. According to the press release issued nearly 12 hours after the incident, the live feed was cut to perform a critical system maintenance. The statement explained that as 3I/Atlas made its closest approach, the sheer intensity of the particles and radiation it was emitting posed a significant risk to the telescope's delicate sensors. To prevent potential damage that could render the multi-billion-dollar instrument useless, a pre-planned safe mode protocol was initiated. This involved shutting down the live data stream, reorienting the telescope slightly, and recalibrating the instruments for the new, harsh environment. From a purely technical standpoint, this explanation is plausible. Space telescopes are incredibly sensitive pieces of equipment. They are designed to detect faint light from billions of light years away, not to stare directly into the exhaust of a massive hyperactive object at close range. Think of it like trying to listen for a pin drop next to a roaring jet engine. You would need to adjust your equipment or risk blowing out your eardrums. NASA's argument was that this was a necessary, if poorly timed, act of self-preservation for their invaluable eye on the cosmos. It was a choice between a temporary blackout and permanent blindness. However, the controversy lies in the timing and the lack of communication. Why was this pre-planned maintenance not announced beforehand? A simple message informing the public that the feed would be temporarily suspended for safety reasons would have prevented much of the chaos. The silence before, during, and for many hours after the event is what fueled the conspiracies. It suggested either a shocking level of incompetence in public relations, or that the safe mode story was a hastily constructed cover for something else. To the public, it felt like being told the fire alarm was just a drill, but only after the building had been evacuated. Furthermore, astronomers and satellite trackers around the world, both amateur and professional, reported that their own instruments did not detect the level of radiation that would necessitate such a drastic shutdown. While their ground-based telescopes lacked the sensitivity of the space-based one, the complete absence of corroborating data was suspicious. If 3I/Atlas was truly emitting such a dangerous storm of particles, other sensors should have picked up some trace of it. This discrepancy led many to question whether the glitch in the cosmos was real, or if it was a convenient excuse to hide what the telescope had truly seen.